Great, we're going to get started. Thank you so much for joining us today. This is our session, so if that's where you intend to be, you're in the right place. If not, enjoy something you weren't expecting. We have Gus Horn here and Dr. Lynette Scott here to talk about analytics with you guys. We were going to do a little polling thing, but the technology wasn't cooperating. So we just want to ask sort of who's here in the audience, so that raise of hands. Who is a chief data officer or a chief security officer? Do we have any folks like that in the room? No, okay. IT management or IT staff? Okay, good number of you, great. Business unit owners? Okay, that's the other part of the room. Any data analysts in the room? Cool, great. So we got a few of you. Great, thank you. Then the other question we're going to ask is, what's the driving force for you being here? So one of them was technology requirements. How about business requirements? Okay, good number of you. New business models happening in your area and having to figure out how do I deal with that? Okay, good number of you. Another one is, I just want to know more about analytics. It's something that is starting to happen in my area, and I need to be better informed. Okay, good. The last one, if it was anonymous, it was my boss said I had to be here, but I'm not going to put that one up there. And the last question, where are you on your analytics journey? So first question is, who's just investigating it? They're just getting started and trying to learn about it. Okay, good number of you guys, great. Collecting data already and started learning how to use it, but want to know more. Okay, good number of you, great. Already using analytics in one or more areas of your environment. Okay, a few of you. And then who's here has been using analytics for maybe a couple of years already? Okay, one guy in the back of the room. So that's good. That's where I expect a lot of people to be. So that's great. So what we want to start out with is Gus is going to just sort of give an overview of analytics and what he's seeing out in the market and some of the trends and things like that. And then we'll come back to Linette and she'll share sort of what she's doing in her area and those things, and then go back to Gus that has some other things to add, and then we'll have some questions and answers from you guys. Is there specific things you want to know about? I'm sure they can help enlighten you guys in some of those things. So let's get started with Gus.
All right, great. Good morning, everybody. Thanks, appreciate you coming. So I was told not to talk about products or anything, so I won't. But I'm a global engineer that travels around the world talking about big data and analytic platforms, and have architected probably some of the largest ones in the world right now today. Things that run Google, Facebook, Yahoo. A lot of these things are all based on the same technology that we're talking with you about. One of the big differentiators, though, one of the biggest differences is that you can't be like Facebook or them, right? And the reason is that if you think about Facebook, for example, Facebook has gone down multiple times in several years. It just goes dead. It's gone. What doesn't happen the next day? The Wall Street Journal doesn't write anything about it. Their stock doesn't go down. Nothing happens, right? And then the other thing I ask is, what promise does Facebook make you? Anybody? Do they promise anything? Well, they do make one promise. They promise to monetize every bit of data you donate to them, right? Because everybody in this room, if you're on any form of social media, if you use Google Maps, if you use anything, you are a data donor. You are freely giving up your information. And it's all flowing into these big data analytic platforms. But the one thing to keep in mind is when we start talking about how these platforms are transforming government agencies, enterprise accounts, the promise is really amazing what's out there. So what you can do with these things is extremely powerful, extremely fast, and very easy to gain insight into your data. And one of the real promises of these big data platforms is it doesn't care about structure. It doesn't care about where the data is coming from. It doesn't care if you want to do a correlation between, chainsaws and weather events to see if there's a correlation. And surprisingly, Walmart found out there is one. Chainsaws, weather, and mattresses are all correlated. because apparently when trees fall, they break roofs and people need new furniture or something. But who knew, right? So the interesting thing is that when our enterprise customers and when government agencies are needing to build analytic platforms, you have SLAs, you have promises to keep. You can't go dead. So if you're in the franchise tax board and, you know, April 17th or whatever it is this year is coming up, your system has to be up and running, and it has to be up and running to look for fraud, to look for, you know, problems in what's happening. If you're using it for a lot of other use cases, you know, it's important that your system stay up and running. And the other thing is it's important that your system doesn't sprawl and get just enormous, because the last I checked, your government, your budgets aren't really growing, right? They're expecting you to do more and more and more with less, and those demands are just continuing to come at you. So I just put basically 3 different kind of things to think about. And I've spoken in New York, for example, to the Department of Health Services there. I've spoken at Columbia University and some other universities where they're looking into healthcare and how they can improve healthcare in the states. These are really complicated problems, and the slightest change in correlations in looking at data or how you provide services has dramatic effect on how you're spending money. You know, so that's the other promise that big data brings, is because you already have a vast amount of data in your own databases, inside your own records. If we think about a lot of the public records that exist for when people buy and sell homes, who owns the house, how much did they sell it for, that's all public information. You have all that data. Other companies are monetizing your data right now, right? They're already doing that on Realtor.com and all these other sites. They didn't do anything special. They're just reading all that public record data. You have it as well. Demographic information, tax roll information, all of these things are important data points that you need to have, because if we look at, for example, in Department of Health and Human Services, one of the things that they found is that certain diseases actually track certain ethnicities. And also there are correlations, for example, between heart disease and diabetes. And diabetes is more prevalent in certain populations as well. So for them, it's a question of how can we start attacking these problems early on before they become huge burdens on the healthcare system. So they're looking historically back in data over 100 years, for example, in the one example that I was looking at Columbia. And they have genetic profiles, they know where the people have come from, and it's a changing demographic in our country, right? So it used to be we were predominantly Eastern, we're European-based. Now we have a lot more diverse people coming in. They have different diets, they have different health issues as well. And these are all going to start to impact our public health system as well. So how you use the data, the kind of insights you get from it are really critical in changing how we're spending our money and how we're treating disease. Another interesting one is proactive kind of thing. So I was looking online and I was thinking about, what does the state of California have? So if I think about just the police department, right, the CHP, I think they have over 1,000 vehicles right now just in the cruisers, right? This the Dodge, whatever, that they're interceptors, they call them, right? But then you also have a fleet of aircraft, you have buildings, you have infrastructure. All of these things are data generators. And if we apply just some smart things about what we look at with this data we have, again, when you make slight changes on how you service and support the vehicles or aircraft or how you maintain your buildings, those slight changes pay dividends for years to come, and lowering your costs and making sure that these things are up and running much better. An example is that there was a very large trucking company that I spoke to 3 years ago, and they have 400,000 trucks in the US. One of the things we did is we put a telemetry device in every one of those vehicles, and we sent it into a big data system. And we started to look at what's happening with these trucks and how do we correlate that with the behavior. So there's some unique behaviors for truck drivers. They keep driving. They don't care if they see a check engine light come on. If the truck is moving, they're moving, because they're paid from point A to point B, and if it's still rolling, they're rolling with it. What they found was that most of these trucks are still under warranty, but instead of having a minor problem, they would drive them until it was a major problem, and it was a major warranty issue. So the minute they implemented this, they decided that they were going to go on Highway 80 and Route 66 and make specific garage bays available and have parts depots for all of their vehicles. And they would literally tell the driver, pull off at the next one. Your part is waiting. There's a repairman waiting for you. Take a 30-minute break. We'll fix your truck. All of a sudden, they saw a dramatic decline in warranty service and actual critical faults that caused them to replace engines and transmissions and major services. The same could be done, actually, I think, in fleets for the state, for example. You know, and if you just look at the police fleet, that's one. But you have all kinds of other government fleets out there, from Caltrans to snow blowers right now that are working harder than ever. And for the last 10 years, they barely worked at all, right? All kinds of problems are probably coming, right? Let alone our dams and our infrastructure that we thought would never get filled up in 2 months, right? So all of these things are coming home. But we have all the data. So infrastructure, buildings, aircraft, all of these things are screaming big data. And how you can implement these can make things better. And then lastly, you know, one of the new things that's really interesting are the kind of algorithms that are available to you. So there's a really interesting person. He's done TED Talks. His name is Jeremy Howard. And if you do a TED Talk for Jeremy Howard, he'll talk about an algorithm called deep learning. And what he talks about is how do we train our big data systems to learn like humans. And that's what a deep learning algorithm is. Instead of you thinking you can brute force train it to look for fraud in taxes, or to look for fraud in the healthcare system, or to find correlations in healthcare with patient demographics, what you do is you teach it to read, you teach it to think, you teach it to do the correlations and present you the answers. So what he described there is how they taught vehicles to see, not just to do image processing. And that's why cars can drive themselves, right? It's not because they're doing image processing, it actually can see, right? So they're changing the way these things are being programmed, right? So that you learn from the data, and that's really the real promise that we see there. The other thing that we like to talk about is that we always have to plan for worst case scenarios, even in the state. You wouldn't put all your eggs in one basket, so we have the tools and capabilities to help you to architect systems that give you the flexibility and really durability that you need as a critical component in the state infrastructure. So having the ability to retain data for decades is important. Also having the ability to move that data to the data centers where you need it. These are things that David can really talk to you about, and I can come talk to you about how we can help build a flexible infrastructure. The other thing that we've done, and I don't know if I have it in this slide or not, is what's happening. Things are getting faster, they're getting smaller, and we're doing more. So I mentioned already self-driving vehicles. That's only possible because they're using what are called GPUs in there, these processor units where you have thousands of processors now sitting in a vehicle. These same things are now being put into these analytic platforms. So instead of having 10 or 20 cores doing the computations, you now have 10 or 20,000 cores doing these computations. So when I studied many years ago in Boston under a professor named Marvin Minsky, it was hard to do artificial intelligence. It was hard to teach or have a system learn because it took so many cores, so many processors, and back in 1990, that was hard to do. Nowadays, you can get an NVIDIA card with 1,000 cores on it, put it in a machine, and now you've got a supercomputer on your desk. It's a completely different world, and it's actually changing how we architect the solutions and systems. So that's the thing to keep in mind, is that you want to maintain flexibility. A lot of times you hear about big data, and you hear about Hadoop and NoSQL and all these things. A lot of times they're predicated on what we call white box commodity servers. They work great for Facebook, but keep in mind what Facebook's promise is to you. Nothing, right? And the other thing to keep in mind is if you're hitching your wagon to a very rigid and inflexible approach to these things. Because if you buy a certain kind of server and you can't put that GPU in it, you can't make use of maybe, you know, artificial intelligence and these learning algorithms because you don't have the compute power. But if you hitch yourself to a flexible architecture where you decouple some of the storage from it and you give it that high-speed tier, now you can have that flexibility to change as technology changes. Because really at the end, the most important thing that you have, it's not the compute platform, it's the data. And you have all the data, that's the key. You have the crown jewel trapped right now inside of a lot of your legacy plan of record databases, or in paper form for that matter. You have all the data. The question is, how do you absorb that? How do you get it in? Because our CEO actually said recently that data is the currency of tomorrow. You already have a wealth of data trapped inside your infrastructure. Its question is, how do you gain value from that data so that you can spot trends and be proactive instead of reactive? Because we already see how bad it is to be reactive on a spillway on a dam. It doesn't work too well, right? You have to evacuate an entire town, and you look at it now and it's like, boy, that really looks bad, right? That's a reactive approach, very expensive, impacts, tens of thousands of people, potentially could be catastrophic and far worse. Much better to be proactive, It's a real easy equation to figure out the cost of being proactive versus reactive. So that's what I want to leave you with. Big data can actually change how you approach things. It can really dramatically reduce our costs. As a citizen of California, it's important to me that we do things right. And I think it's important that we use your resource, and the biggest resource you have is the data. So hopefully that has sparked some questions, and with that, I turn it over.
Okay, great. Thank you.
Hopefully I didn't talk too long.
Well, it's a real pleasure to be here. So my name is Lynette Scott. I'm the Chief Medical Information Officer at the Department of Healthcare Services in the Health and Human Service Agency. And part of my role, and just out of curiosity, I'll sidetrack, how many of you have ever heard of a CMIO? Anybody know what that is? So let me explain part of what my role is, and then part of use that to lead into the topic. So the Chief Medical Information Officer is a role that has been emerging as electronic health records and IT automation have come to healthcare. So I'm a physician. I went to medical school at Eastern Virginia Medical School in Virginia on a Navy scholarship, spent 5 years as a physician in the active duty Navy, and then moved here to California. My training then proceeded with preventive medicine and public health. And so I'm a board-certified preventive medicine public health physician, and also with a subspecialty in clinical informatics. So what that means is I'm a physician that can talk data and can talk IT and translate between the business and the technology. So some of what you heard from Gus was around some of that technology base and where it's stored. And I love being partnered with our CIO, our Chief Information Officer, who is Barney Gomez at Healthcare Services. And he definitely worries about all of the technology and what it sits on, how it stays there, how it's supporting all of those pieces that Gus was talking about. I tend to focus more on what sits in the technology, and then how do we get it to folks like Tanya in provider enrollment to use it, and what does that tell us about what's happening in the organization and to our population. So it's that kind of translational role. And we're seeing more CMIOs emerge in the healthcare arena. So in that context, very much focused on how do we use this robust information that we have, and we do. We collect a tremendous amount of data in government, right? But we have COBOL, mainframes, things that are not real useful in terms of analytics. And there's a lot of folks that are coming around saying, we have the analytic tool for you. And then it's usually followed by a nice flashy display and this thing that looks really cool. And you're like, great, so how do I do that? And then you start talking about, well, where does your data actually sit? How is it stored? How is it coded? And the question comes, well, what is the question you're trying to answer? And then you stop and you say, well, that's probably a good question. What is it I'm trying to answer? And so I think part of where I want to focus is that space of you have a ton of data. There's lots of tools. We talk sometimes at Healthcare Service about the fact that we have almost every tool available because we've done various purchases over the years. We're a large organization. But how do we make that come together in a more cohesive way? And there are a number of tools. And so part of what I want to share with you is a kind of a set of tools that you can go use to then resource and think about how you want to move forward in this analytic conversation within your organization.